Before we start, I would like to introduce our trainer for this workshop, Mr. Snehashis. He's a group manager and principal consultant at EvalueServe. So, with a strong experience in data science, machine learning, and analytics across global clients, he has worked on large scale data projects and has guided many students and professionals in building successful data science careers. So we are very happy to have him with us today. So like from day 1 to 3, like we have this workshop from 7 to 9. The last hour on Saturday will be a special career guidance session by our co-founder covering how to get data jobs and current market needs, how to build the right roadmap, what companies expect in the interviews, and IBAC global certification value. So there are some important instructions here I would like to give. There are like we have many participants today, so please stay muted throughout the session. If you have any doubts, please type your questions in the chat. It will be addressed. So please try focus and avoid switching screens. All the participants who attend the workshop will receive an official participation certificate from Eduinx. This will be enrolled to you next week. Okay, this will be emailed. So thank you once again for joining. We hope all these 3 days give you a strong start to your data science journey. Now I hand it over to Snehash sir to begin today's session. Thank you all. Sir, over to you.
Thank you, Priya. And good morning, everyone. Welcome to this 3 days boot camp. So, as Priya mentioned, I'm Snehashish. I've been working in this field of data science for a long time, for over a decade plus. And in this course of period, I've worked on various data science courses and the fields, which include some advanced fields like computer vision as well as Gen AI. So, before we dive into the data science, what is data science, and learning the various components of data science, first let us understand in this particular scenario that uh, the world that we live in, why data science is so much important. See, as you can see, uh, throughout any industry right now, every place analytics is playing a very big role. And data science is one of the fields where, whether you are in a healthcare domain, whether you are in a banking domain, whether you are in a telecom domain, or whether you are in any other manufacturing domain, this is one skill that will enable you to work across any industries. So, in short, you will be industry independent. Your skill sets will apply to everywhere. Yes, there will be a little bit business knowledge that you will need, but the base for you will be covered for you to apply and work in every industries. The restrictions that some of the other technologies bring in, for example, if you are mostly working in mainframe, then you might be restricted to banking domain itself. These kind of restrictions may not apply or will not apply in the data science domain. That is a very big advantage in today's world. And if you see the future trends that are coming in course of time, you will see this particular field is getting involved or into other things like robotics, uh, which is the next big thing that is going to come. But for that too, you need a deep understanding of the data science. So this is what I wanted to start with, because before you jump into any kind of course, you need to understand what this curriculum is going to to you, give an advantage to you. This is the right time to jump. This is the right time to make a call because the opportunities are endless. So, with this, let's start today's session. I'll be sharing my screen. So, what is data science, first of all? You are hearing now in the market a lot of things about data science, Gen AI, agentic AI, AI agents, various lot of jargons. But data science basically it is analyzing the data and trying to find insights from the data. This is the base of this. So even though there are a lot of new things coming up, people trying and telling a lot of things, data science is actually was created or the work was started a long time back, 40s, 50s, a long time back. But it came into prominence just now because the computational power was available today. It is not a new topic that it is being looked at the research side. Only now the fact that the computation is there, the amount of data collected is there, that the effects of data science is being seen. And like I was saying, that the base definition of data science is using data to find out insights. Whatever the problem statement being given to you, whether the customer is going to stay with your bank or stay with your organization, or the employee is going to stay with your organization or not, everything, you study the data from the past and you apply machine learning on top of it and you find out the output. Now, in a small sense, it can look very simple, but it is actually not. In data science also, the base which data science actually works at the back end is probability. Probability, you can say, is the mother or the father of data science. In this particular period of 1 or 2 days or 3 days, what we are going to see is what are the few components of data science, what are the basic types of data science, what are the basic types of machine learning, what is the skill set required for a machine learning to be performed, some sample codes, so that you get a flavor of what you are going into and make an informed decision. If you see some of the examples of data science where it is used right now, or the data science use cases, realistic example, I think many of us would be using Amazon, Flipkart, places like there where we go out and shop. But what is coming in front of you might be different for another person what it is coming. It's more like a web page that is personalized to your need. Example, if someone is looking into more of electronic items or furnitures, that person's recommendation would be most coming in the form of, if a person is browsing through more furnitures, he will get more recommendation on the furnitures. If a person is browsing through more electronic items, he will go get into more of the electronic items. So this is how the base for, give me 1 second. So this is how companies like Amazon and Flipkart see the past trends of how you have browsed through the platform and giving you the details like, okay, this is the person who's mostly interested in things like this. He spends on an average this much amount of money, and this is the time period that he normally spends. So based upon that, these kind of products are the ones are the things that this person needs to be given a recommendation for. But is this an easy task? It is not an easy task. If I as a person go to the on go to the website of whether Amazon or Flipkart and see that whatever I generally shop, it is not showing me those kind of things on top, then I might lose my interest. And then I will switch to someplace else. So that leads to a loss at the client side. So when we decide on creating an output in the field of data science, we have to be very much cautious. The impact is huge. It can lead to direct revenue gain or direct revenue loss. One more example, banking domain. Now, many of us go to the bank and ask for a loan. When you ask for a loan, what the bank does is it checks your various back-end transactions, how much loans you have taken, what is your CIBIL score, everything. What is the money that is left in your account on an average at every time? All these things it checks. It may not tell you, but it will check everything. And it will give you a risk rating internally. Suppose the risk rating is from 1 to 5, where 5 is the highest risk, 1 is the lowest risk. So if I apply for a loan and I've been given something 1 or 2, saying that this person is actually a low risk customer. But in reality, I should be a high risk customer. Then the bank is giving me a loan at a low interest, which means that the bank is giving a customer a loan at a low interest where the customer can default, NPAs, non performing assets, which leads to direct loss for the banks. And when there is a loss at the bank, at an industry at the bank level, it also impacts the national GDP. I'm telling how critical that sector is. Similarly, if I am a very good customer where I actually should be given a loan at a very low percentage, but the bank internal algorithms, it is telling that, okay, this person is actually a high risk, which means the loan that they are giving to me is at a very high interest rates. Then there is a problem where I as a user can approach to other bank and get the loan. In this particular case, the bank is losing a potential customer. That's why you see many a times loans being there with one bank, other banks try to bring that loan to their own banks, transfer of the loans from one bank to another. So you not only have to predict what is the security level of a person, risk level of a person, you also have to make sure that they are as much correct as possible. Any up or any down will have a huge impact. Let us take some other example. Manufacturing. In manufacturing nowadays, what happens is there are a lot of parts of a component of a car or a bike which may not be real, which are duplicated parts. Advanced data science algorithms are able to track whether that component is actually that is created by the parent company, or is it a fake product. Because when a fake product goes into the market, it destroys the company's name. Many of you would have heard about the company Robert Bosch or any other company like this, which is considered as they produce very good products for auto components. Just think if their auto components, which are also costly auto components, are being given to you, which are fake, or these companies, when they get components from their own suppliers, they are not actually up to the quality level that it needs to be. So that time data science helps them. There is a field of data science called as computer vision. The Tesla cars and everything that you see on the road, the self-driving cars, they are using computer science. So it is just not restricted to number crunching at the desk level. If you see now, products like Tesla, products like Apple, I'm not telling you about the intelligence that they are bringing in, but simple, like if you see the new Apple product that has come, that converts human languages into the native Spanish or German, few native languages. They are doing that through data science. The field that takes care of that is called as the speech analytics. So everywhere, if you see, analytics is now playing a very big role. And in fact, the product that you are buying for your own experience, the X factor, the ease of using at the user level, at your level, is based upon the fact that how good your analytics is there. The Samsung phones that you take and you make sure that you edit the images. If you remove the glasses from a person's face, how the person's eyes would look like. That is also done through analytics. And people use that a lot. Even one of the main highlights of a product is the way that it can capture images and it can allow editing of the images. And in this field, there is a new thing that has come, which is Gen AI. Gen AI is a traditional machine learning or a data science algorithm, but trained on a huge amount of data. Wikipedia, any other coding aspect, online forums, all this kind of things, encyclopedias, all this kind of things, Gen AI is trained on. But what is the difference? Where is Gen AI different? So till now, the use cases that we were seeing is something was shown in front of you, whether this person is a fraud or not, this person's what is his credit rating, the thing that you are seeing in front is an obstacle or not. Till now, these examples you were saying is whatever was kept in front of you, you were analyzing that and giving an output. This new area of Gen AI, where it is slightly different, is it creates new output for you. It creates new output. That is why the word generative. Traditional data science techniques used to label things. Generative AI is something which creates new stuff for you. You want to create a new poem, you want to create a new image. That is why generative, that word comes in. And it does that by learning from very, very huge amount of data. I will stop here for 2 minutes. If we have any questions, we can take. Okay. I think everyone is clear on this. Now, with this understanding, let us see, when you start in this journey of data science, what are the key aspects that you need to go through? What are the key processes? The first is data collection. Data collection is where you collect your data from various sources. You can collect your data from web, You can collect your data from databases. You can collect uh, your data from some Excel sheets, whatever the data sources are. And the quality of that data plays a huge role. See, remember one thing, no matter how good you are as a data scientist, if your data is bad, you cannot create a good output. So your data has to be good. And when I say what is the terms of what is your data has to be good, that means it should not have many missing values. It should not have many abrupt or sudden values which are out of scope. Like, for example, if all the values are between 1 to 10, suddenly you find a value that is 110. In machine learning or in the data science area, we consider that as an outlier. So if your data has most of the values, missing values, or what you are trying to find, for example, if I have an input, let me showcase you one thing. Suppose there is a data set or there is a tabular column which has age, risk, salary, and I'm trying to find the risk category. This is my output, suppose, what I'm trying to find. And this is my input. This is my input. So, the first step is always to understand from the past historical data how n number of values 20, 21. Suppose like this we have till here. Risk category, suppose A, high. Risk score, let me give it as risk score. Let me remove this at all. It will confuse. Salary, let me give it as salary. 20,000, 25,000, 23,000. All this is the risk score. All this is the salary, suppose. And this is the risk category: high, medium, medium. low, high. So what we do first is we first try to understand historically, that means from the past data, what is the relationship for high, medium, low with the input age and salary. And when we have learnt it, that means it can be thousands or lakhs of records where we have learnt the fact that okay, when the age group is between 20 till 25 and their salary range is between 20,000 to 30,000, the chances of a person is of a risk category is high. When the person is between 25 to 30 and his salary is between 30 till 40, the chances of his risk category is medium. Likewise, for the low, suppose 35 till 50, his salary may be 40 and above. So, this is suppose the learning from the past that my machine learning has learned. So, anything now that comes after this, when I try to predict that if a person comes with 20,000 salary, then my machine learning will say that okay, this person based upon my past learnings is actually a high risk person. So what is the machine learning doing? Machine learning is trying to learn from the past all the data trends, and when it has learned with some sort of an accuracy, suppose 93% accuracy, then when you are taking this data science model to production, it is telling you okay, with this kind of an input, this person should be this. Here, if your data itself is very bad, if it is empty, and that too in most of them, then your machine learning can't learn at all. So, for a data science, the first step is data collection. Your data has to be as much good as possible. Else, there is no point of doing stuff. Then comes data cleaning and preparation. This data cleaning and preparation and data analysis, this is around 80% of the work. In data science, there is a very common terminology, which is junk in, junk out. If your data is junk, you will get junk output. But your data will never be good, never be very good data. For example, if you are going to a banking sector, many of the times there will be corrupt data. Many of the columns might be missing. Sorry, many of the uh, rows might be missing. But there is a way to impute that data. You have to find out a way a statistical way of filling those missing values. Filling those missing values. See, this is an information, but this is not a complete information. So you have to find out a way of filling those missing values. You have to treat the missing values, make it usable. So there are a series of steps that we do. Missing of values, treating of outliers, and remember one point very clearly. A machine learn in data science, the model that we create is always more of a generalized model. If there is a machine learning model with 100% accuracy, then it is a bad model. This line, a machine learning model with 100% accuracy is a bad model. Why I am saying this bad? Is because of the fact that that time the machine learning algorithm, whatever algorithm that is there with me, it has learnt the data too well. It is like how in our school days our teachers used to say, don't mug up the data. Same way here also, if a machine learning algorithm mugs up the data, that means it will get around 100% accuracy. So we need to avoid those things. So there are series of steps that we do to make sure that it is good, but it is not 100%. So these forms parts of a data preparation step. Then comes data analysis. See, generally what we'll have is, if you are trying to predict one output, you might have around 100 columns, but many of the columns may not be required. Definitely will not be required. The best machine learning models are models which are simple models. Are simple models. And simple model means less columns. So if there are around 100 columns here, we might bring it down to around 10-15 columns. We might choose which column is actually, if there is one column here, column A, suppose I am giving, for example, BMI index and height, weight. Suppose these are three columns and I'm seeing whether the person is healthy or not. And there are a few other columns. BMI index is very much related to height and very much related to weight. So we don't need to take all these three. We have to take only one. Statistically, if you take all these three, it will lead to errors. It will lead to errors called as multicollinearity. So all this kind of analysis we have to do, that which column needs to be taken, which column doesn't needs to be taken, which column there is a need to take it. And then when we create all these things, we have prepared the data, we have cleaned the data. Means first we have collected the data, we have cleaned the data, we have analyzed and found out, okay, out of this 100 columns, there are this 10 or 15 columns which we need. After that, when the data is prepared, then we go into the modeling. What is modeling? Modeling is basically a mathematical algorithm which is learning the relationship between your input and output. Mathematical column which is learning the relationship between the input and output. Suppose we have an equation, for example, I'm saying suppose we have an equation of y is equal to mx plus c. This is a simple linear regression, which means y is my output. Y is my output. Suppose in this particular case, this is my x. This is my y. It is telling me the relationship of y with respect to x, where m is the importance of x, importance of x, and c is a constant. So you have many machine learning models, and based upon the use case, you will have to choose which machine learning model you want to apply. Plus, you also have to see the data. So if we divide the data science, it will be one traditional machine learnings. Then there is neural networks. Traditional machine learnings are something like linear regression, logistic regression, XCB boost, random forest, all these things. But after that, they started to create machine learning algorithms which were meant to mimic how our brain works, human brain works. That is what led to the creation of neural networks. It's in 1950s or 60s they created these neural networks. It is using these neural networks only that today we see all this Gen A, chat GPTs and everything. They're all created on this. Gemini, chat GPTs, everything is getting created on this particular neural network. So I'll stop till here. I will hand it over to uh, Priya for now for the doubt session till what we have learned till now. Priya, over to you. If anyone has any queries, we can see.
Guys, if you have any queries, please post in the chat box.
So Hussein, EDA is called as exploratory data analysis. Exploratory data analysis. Let me write it down for you. Exploratory data analysis. Exploratory data analysis is where we find out what is the relationship between the columns statistically, and from there we take a call which one to use and which can we can eliminate. See, if there are, I'll take you as an example. If there are two or three columns, A, B, C, D, this is my input column and this is my output column. Through EDA, I will try to find out how A and B, A and C, A and D, B and C, B and D are related to each other. Along with that, I will also find out how A and output is related to each other. So all this kind of relationship I'll try to find out. And my final goal would be output, for example, Y, suppose I'm considering this Y should be dependent upon B, suppose if it is dependent upon B and C, but B and C are not interdependent upon each other. That means they are no longer related. B and C are not related. So it is this process where we do a series of steps. It's a big module, EDA. It's a series of steps through which we find out the relationship. We go to the customer, to our client base, and tell them that this is the relationship that we are able to see. Is this relationship correct? Is there any other relationship that you want to tell us? So when you are making the presentations to the client, it is the relationships that you are seeing as part of this becomes very, very much important. For example, if I am going to tell to one of the clients that the loans that you are going to give for a bike loan, I see the people from 20 till 30 age group having a salary of this much percentage. From my historical data, I can see them not only taking a lot of loans, but also they paying it back. But there is a risk percentage. So when you're giving a loan to this particular age group, make sure that your risk is between 2 and 3 because there are chances of default as well. So this section of analysis is where you will get all these details, all this interrelationship between the columns, between the variables. In our machine learning lingo, we call them variables or features. Variables or features. This each column is called as variable or feature. Age is, for example, age is a variable, salary is a variable, risk category is a variable. This output is what we call as a target variable. Target variable. This is called as input variables. Input variables. Input variables or independent variables. Independent variables. These. This is target variable or dependent variable. This is dependent upon the input factors. So that's why this is called as dependent variables. Yes, guys. Any other questions? I hope this is clear, Hussein. Now, what is the, if, let me continue. After this, we'll take a 5 minutes of gap and then we'll go to the machine learning part. So, what are the core skill set that you will need for data science to be able to be a data scientist? Number one is stats, probability. See, understand one thing. Whatever we are going to tell or conclude, it has to be statistically proven. So, interpretation of the outputs statistically wise has to be understood. There are few concepts, p value and various kind of distributions that you have to learn. You will have to understand that, okay, if I am saying that, for example, age is important or salary is important, I will have to prove that statistically. Second, programming skill set. Programming skill set is where initially we there was other languages like R and various things, but now the programming skill set is Python. It is an open source code. It is a Python. But just Python won't help. Along with Python, you also need to, for collection of data, especially, you need to also know SQL minimum. Once you have this statistically and Python coding skill set, that time when you will be able to see that whatever assumptions or conclusions you are making about the data, you are able to see that, because all these statistics, all these things you will be doing using Python itself. And this machine learning also you will be doing through Python. There are libraries in Python languages which you will be calling, or there are codes, shall I say in very simple words, which you will be calling in your Python language for statistical purpose and also for machine learning purpose. So Python is kind of a medium for you to perform machine learning and stats. Communication. This role involves a lot of business communication. You will have to drive calls with the business, asking what you need, what your findings are, and maybe even challenge their findings, because what the way you will challenge them is through data. And when the data says something, it is very difficult to go against it. The only place where the business might have a more advantage as compared to you is the business knowledge or the domain expertise. I might be given a set of data to deal with, but it might not have a very significant column, or the columns which are actually should be there, only the business expert can tell them, which means that I also, my communication should be in a way with my business partners that they are confident on my work and they're also willing to share the knowledge that they have with me. So relationship and rapport becomes very, very important. It is a client facing role. It requires you will have to present as well. Frequent presentations will be there. So with this, I'll stop for now. It is 8:12. Let us connect at 8:20, and again, then we'll go for the machine learning part. Is it okay, Priya? Let's give everyone a 5 minutes break then. Or else, if anyone has any queries, they can add it up in the chat. I can just look into it. Okay. Let's again connect at 8:20, uh, giving you 5 minutes break so that we can again connect back. Let me take the questions. Okay. Uh, where can we get the data set? See, Sharath, for the practice sessions, you can take the data sets from online repositories like Kaggle and various places. But realistically, in the project, how it happens is, I'll share my screen again. Is you will have your data source, input data source, which can be your Teradata or Oracle DB. From here, the code that you are writing in Python, you will have to establish a connection, establish a connection, establish a connection to the database, and then you will have to write your SQL code to extract the columns. Then you will do all your development there. Now, initially, you might extract hundreds of columns, but when this code goes to production, that time you will, based upon the EDA and all the analysis that you have done, instead of 100, you might end up only extracting 20 or 15 columns, whichever columns you believe is important. But this too has to be there. You have to establish a connection and you have to write an SQL code for that. That is in real time projects how it happens. I hope it is clear as a practice and in the real time how it happens. Any other questions? Okay, let's start with the session then. So this is an overall what it is. This picture. The biggest among them is AI. Everything is AI. A part of that is through a bigger part of that is machine learning. Under machine learning, one of the techniques is the traditional machine learning techniques. Hello. One of the techniques is the traditional machine learning techniques, and one is the neural networks, which I was telling, which mimics human brains. And it is using this neural network that Gen AI models of today, ChatGPT, Gemini, Grok, all these things are getting created. So the only difference is for Gen AI, it creates new data. It creates new data. The other, as of now, all the data science used to tag or label the existing data. Gen AI will create new data. They have a concept among them called LLM, large language model. LLM, large language model. What is large language model? Large language model is basically a machine learning model trained on huge amount of data in text, in text or in videos, anything. So from this forms the basis. LLM forms the basis and Generative. So the free parts, if you want to try out some of the free, see ChatGPT is like it is paid. But if you want to have some free, then you have Llama from Facebook. There is a free model that you can try out. And this part of machine learning. So what basically is machine learning? Machine learning is once you have taken all the prepared the data fully, it is then learning the relationship. It is then learning the relationship. Basically, and if you have to define what is machine learning all about, how many types of machine learning are there? Machine learning is of two types, primarily supervised and unsupervised. What is supervised? Supervised means you have in general what we have an input and an output. Suppose this is the data set. This is the data set. An input and an output. This is the X. This is also X. And this is the output. When you don't have an output, it becomes unsupervised. Which means this in this particular case, where I know what is the input that I need to give and what I need to find out from my data. What I need to find out from my data is called the output. Is called is called the supervised machine learning. When this is not there, only I have the data. My business or the data that I have got is just the data. I don't know what to do with the data. They have just given me the data. They have not given me any problem statement. That time it becomes unsupervised. Examples: customer segmentation. Every place, in banks, in retail sector, every place you will have this customer segmentation. They will take the full data and they will try to divide it among various kind of factors like high spending, low spending, medium spending. They will decide. They will try to divide the data. That means you have a data and you're trying to find out insights. Is there something I can use from this? What that something is up to you. That time it becomes unsupervised. When this is missing, it becomes unsupervised. When it is there, it becomes supervised. These are the two basic parts of types of machine learning. If you go one step ahead, if you go one step ahead, what you see is when you do machine learning, there are future more two categories. One is classification, one is regression. That means when your output is in class, high, medium, low, apple, orange, it's a class, it's a discrete number, it's a group. That time it is called as classification problem, machine learning classification problem. So, for example, if I tell you, if there is a use case which says that please this is your set of data set, we need to train and find out which person is a fraud and which person is not a fraud. It is a very common use case in banking sector or in the retail sector. If I have to say that this person is going to leave the company or sorry, leave uh, the product, and and this person is going to save. So leaving in data science is called as churn. Churn. So these kind of use cases where the output is one category, high, medium, low, is he going to leave, yes or no, that time it becomes classification problem. But when your output is continuous in nature, means output value is something 100.2, 100.23, it can take any value. For example, what is going to be the price of a plot in Bangalore? It can be any value. Yes, it can be within a range, but it can be any value. So it is a continuous in nature. It can be 1,000 rupees per square feet, 1,001, 1,200, 1,300, anything. So that time it becomes a regression problem. So in machine learning, you will understand that many of your fellow data scientist peers, they'll say, okay, this is a classification problem, this is a regression problem. That time you need to understand that, okay, this is classification, they are going to identify the classes. They are going to identify the continuous parameters here. So like that, these are the two types of problems that you will be basically dealing with. Any questions? See, this is what I was trying to tell. What data that you are going to deal with. Every information is a data for you in data science. It can be an image, it can be an audio, it can be a text, it can be a string, anything. That is a data for you. It can be qualitative, it can be quantitative. By qualitative, what I mean is basically categorical in nature. Quantitative means it is continuous variables. Based upon these, your machine learning algorithms will also depend. Based upon these, your machine learning algorithms will also depend. Some algorithms can be done only for classification. Some algorithms cannot be done for regression. Some algorithms can be done for both. And the best way to do a problem is to always make sure that if suppose there is three algorithms that can be applied for a classification problem, you try out all the three and see which one gives you the best of the results. So if you see the tree chart, if you see the tree chart, machine learning basically supervised, unsupervised. There is also reinforcement, but reinforcement is basically for robotics. That is where it is used. Supervised and unsupervised. Supervised can be classification or regression problem. Unsupervised, it is basically you don't know what is there in the data. You're trying to find out. That time what you do, you try to group the data and try to see what is happening. For that, there is a separate machine learning algorithm for that as well. Now, this is something that we went through Python, R, and SQL. R was initially used a lot. It is still being used by, but majorly by stats people. But data science has fully moved on to Python. Now, in Python, there are few. See, Python as a library is huge, but we are not coders. We are data scientists, and data scientist means we need to know some concepts of Python that is needed for us to play around with the data. I'll tell you something, few of them. Whenever a data science problem comes into, what we do first is we try to create a something like this, a data frame. A data frame is something sort of a table which has all your columns and rows. When you divide it and try to take it into each one of them, it becomes a series. So, if you see this, NumPy, Pandas, Matplotlib, Scikit-learn, TensorFlow, SciPy, these are the major libraries that you will be working. NumPy is for numerical computing. Pandas is for creation of data frame and manipulations. Matplotlib and Seaborn, they are basically for visualizations. Scikit-learn is a library in Python which contains all your machine learning algorithms. TensorFlow and Keras is something that you use in neural networks. I'll park that as of now because neural network is very, very advanced topic. SciPy is something that you use in Python for stats. Don't get afraid of all these things because once you start using it, you will understand it that it is, you just need to know that what is the step that you are trying to do. What is the step that you are trying to do? and based upon that, these columns will come to you automatically. For example, initially if I want to read the data into a pandas data frame, into a data frame, I want to see what it is. I'll first use the pandas. I want to see the visualizations. I'll use the matplotlib. I want to do the training. I will do the scikit-learn. So these are steps which are already predefined. The problem will come in between when your data is corrupt and you are trying to choose some parts of data. See, let me showcase you an example. This suppose this is what generally we use. There are many tools like this, but there is a tool which has been used from a long time, which is called as Anaconda Navigator. When you download this Anaconda, you will find something called as a Jupyter notebook. You press the launch button on the Jupyter notebook, it will open something like this. Or let me launch it again, maybe for the benefit of everyone. See, it is launching. Hold on. So it has launched it like this. This is the Python code. Suppose I'm going to start to write. Initially, whichever libraries, see, there is, before we go there, understand. Python is a programming language. Under Python, there is libraries. What is libraries? Libraries is predefined codes, predefined codes to perform a specific task. For example, if there is a library which is there to add two numbers. Suppose I have created a library called as sum. So whatever this sum is a library, and whatever you give input, suppose 1, 2, it will add that up and it will give it to you. But inside that sum, there is a code that is written in Python. So in Python, when I import sum, I mean I am calling this library I'm calling this library as suppose SM. And to this library, I'm then passing my value 1 comma 2. I'm just trying to tell you how the flow happens. That there is a Python programming language. Under Python programming language, there are a set of libraries. Every libraries will have many predefined codes in them. Many predefined. It may have one or it might have many. Like sum, multiply, addition. This all is a code within itself. This all is a code. They might be part of a library called as math under Python. So when I try to call math, that means these all libraries will also be called. In the same way, in generally what we do is we first open the environment. In the environment, we call the libraries that we want. Python is a huge stack. We don't need all of them. We call the libraries that we need. Pandas, NumPy, sklearn, various kind of things. Instead of taking this exam, should I take this? Okay. Okay, let me take this. Then what we do, we then try to read it. See, I called means I came here, I gave shift enter. When I gave shift enter, it ran. So one. If I give again, it ran. Now suppose this is a data set that I'm trying to read. See, I have imported. Import means bringing the library. Bring that library in your area where you are working. Import. I am importing pandas as PD. I'm giving it a name as PD. I can give anything. I can give PD, PI, anything I can give. But this is important. As PD. I gave PD. Then I gave this one where I know this is in an Excel sheet format. I read it. This, when I do like this, I see all the data that was there in this Excel sheet. Now, if I see, I have read it into a data frame, and here I can see all the columns. All the columns. These are the steps that I'm doing. These are the steps that, as understanding the data and cleaning the data, you will also have to do. I see, okay, these are the steps. I try to see what is the column types in each one of them. I see price as int. This is an integer. This is area is a float. Float means decimal. Int 64, float. All these things I'm seeing. Objects means categorical in nature. So every column I'm seeing what is the aspect of that. What is the column type all about? Then if you see what I'm doing is I'm trying to check. Maybe I'll just skip this step right now. This is a little bit uh, more technical. I'm trying to see how many NA values are there. I see area with two NA values, bathrooms with two NA values. Empty is something that I cannot use. So what I do here, I have to fill in the data. Then here what I'm doing is I'm filling in the data. I'm filling in the data. Now if I go and see here, it should be filled in. If I give the same command here, if you see bathroom was or area was two missing, now it is all filled up. Just try to get an idea of what I'm trying to do. We'll take an example and try to do one code full. But today's session, just try to see the steps that I'm trying to do. So like this, there are many steps that we need to follow. I'm in this particular place, I'm just introducing you to the Python and the libraries, how it is, how they are being called. Here, for example, if there is sklearn, if I have to call sklearn, see, I have imported sklearn. Sklearn dot tab, if I press, excuse me, it shows you all the options that is there. That means this is a library which contains all these internal codes, modules. See, when I was reading this data set, equal to PD means pandas, PD dot PD dot. If I press tab again, it is showing me so many options. Since my file was Excel, I gave Excel. If it was CSV, I would have given CSV. If it was been JSON, I would have given JSON. So since I know the format, I have chosen that format I have given. Similarly, if you see, there are few concepts in Python like list, Why is it not working? Give me one. List. List is something where you can store multiple items in a single variable, and they can be of any data type. They can be of any data type. This is numerical, this is categorical in nature. So here, if I have to create, suppose I'm creating a list here, test underscore list equivalent to 1 comma hello comma 23. Shift enter I gave, then it got created. If I give T tab test list and give shift enter, it gives me this value that inside this variable it is a list and this is created. I give D types. I give type before it. It tells me what is this. This is a list. Similarly, there are other components also. Dictionary. Dictionary means a data is stored as key and value. Key and value. See, what is now, if we are learning lists, if we are learning dictionaries, there has to be a need for it. What is the need for it? Suppose area or price. I want to make sure that I choose area value of this and this. Sorry, price value of this and this to be replaced with some other value. So my input is a list of values to be replaced by another list of values. So in these kind of operations, you will need to use these kind of activities. This is called data manipulation or data preparation. So these things will come helpful there. Similarly, there are other types as well which helps you. For example, you have a data set like this, you got the info, and you want to see what is the minimum and maximum value. So there is an option called as df.describe. you see what is the count, what is the minimum value, and what is the maximum value. But what is all these things helping you? All these things are helping you to understand data. Understand data. To, if there is a need for you to replace some data points in data, you need to know what is the maximum values that you can replace it with. Replace it with. So that time these kind of functions, there are other functions called as length. Length means suppose this is having 3 input variables in this one. So if you give length here, it will give 3. Now if I suppose add one more here and give here, it will give 4. So it will tell you what is the length in this. If you give the length for this particular data frame, it will give 545. So all these factors which you are seeing, it will help you to understand what data you are dealing with so that we can take a look at it. So what we will do is in our next session, we will take will concentrate more on a use case. We will see few of the standard steps and then we will see what is the output of that. If anyone has any queries, please ask me. Yeah, the object basically it will be a string means, but it will be taken in here as a character itself. Categorical itself. You can use PyCharms and various other this one as well, but Jupyter is the one that I have seen mostly people use. Means it is the most widely used till now, uh, especially for the learning wise. I would definitely say Jupyter is the most commonly used, but PyCharms is also now commonly used as well. I think in the others, um for the Gen AI aspects and all, more than the Jupyter, the other I think WS codes is what is used there. But you can start the basics of the data science with the Jupyter. Okay, guys. Tomorrow we'll see a code where we will start playing around with the code a little bit more. We will also go through the visualizations a little bit more so that we can understand on the code basis what what is the flow happening on the coding side so that you get a better idea of it. We'll wrap up here. Uh, if there are any questions in the next class, first starting 10 minutes, we'll go through the questions only. Thank you, everyone. I hope it was useful. Okay, I have a thank you.